Welcome students, we come back again with a new video that can give you enough knowledge without giving much effort. Now what do you think? This session is too much boring? Not that. It can give you the important problem solve, okay, for your 12th board exam also. In this video, we discuss about the electric dipole, okay, and also one of the main things, that is the different cases of the electric dipole. We just want to find out the electric field at any point on the axis of the electric dipole and also find out the electric field on the equatorial line, okay, and we also find out that is the electric dipole on an uniform electric field. These three cases we discuss in this video, and after that you can solve any problem related to this part, that is the electric dipole. Okay, then don't waste your time. Open your copy, take out your copy and pen and note down each and everything that is given, that is explored in this video. Okay, so let's start our journey with the electric dipole. Okay, so first one, electric dipole. So first question arises in your mind, what is electric dipole? Electric dipole, the terms, okay. From these terms, we just consider first one, that is the positive charge, plus Q. Another charge, we consider this one is minus Q. So these two charges, that is plus Q and minus Q, the value of the two charges remains same, both are Q. Only separated that this one is positive, this one is negative, okay. These two charges are infinite. If I consider these two charges is infinite, okay, and the distance between them, it is considered this one is D. If the distance is tends to 0, this distance is tends to 0, then this arrangement, this configuration is called the electric dipole. So this one is called the electric dipole. So what I am telling, that is two charges plus Q and the minus Q, these are separated by a distance D, okay. So plus Q and minus Q, these two charges equal and opposite in polarity obviously, and the distance between them is D. When the distance D is tends to 0, then we can say that this is called the electric dipole. Now when we discuss about the electric dipole, two questions arises. This is the main things, that is axial line. What is the axial line? What is the equatorial line? So we come back to the first points, that is the axial line. So what is axial line? So consider the first dipole, that is first charge plus Q, and the second charge, this one is minus Q, okay. So separated by some distance, this distance is considered that between the plus Q and minus Q is 2L, okay. So the distance between them is 2L. This line joining the line between the two charges, that is the plus Q and the minus Q, that is the dipole, okay. The line joining the dipole is called the axial line. So this line is called the axial line. So now it is clear what is the axial line. Axial line, that is the line joining the two charges, okay, and the distance between them is the 2L, okay, between the two charges. So if I consider another line that is perpendicular to the dipole, and this perpendicular passes at the center, the point O. This point, this line, straight line perpendicular to the axis, it is called the equatorial line. Okay, so it is clear now. So this one plus Q and minus Q separated by some distance is 12. This is the dipole, and this is the straight line. This line is called the axial line. We draw a perpendicular. This is passes to the center of the axis of this dipole. This line is called the equatorial line. Now it is clear. So this one is axial line. This one is equatorial line. So another one, that is the electric dipole moment. So we just discuss here. That is the electric dipole moment now. What is electric dipole moments? These two charges, plus Q and minus Q, separated by some distance, that is equals to dl. Okay. So electric dipole denoted with the vector P. So P vector, that is the value Okay, so P vector, that is, so what is the electric dipole moment? It is the product of each of the charges. What is the charge? Q. We can take any one, that is the Q only, okay? And the perpendicular distance between them. What is the perpendicular distance between the two charges? That is equals to 12. So we just write Q into 12, that is equals to 2QL. So 2QL represent the electric dipole, okay? So this electric dipole moments. So these electric dipole moments, this is represent a vector sign, so this is the vector quantity, okay? And these directions, it is obviously along the axial line. So this P is represent the electric dipole moments, and it is the value is 2QL. If I know the value of L, that is the perpendicular distance, and the any charge Q, okay, then we can multiply this, we can find out the value of P. Now we discuss about the different cases related to the electric dipole. After that, we can discuss the uniform electric field. Okay. Okay. So electric dipole, the first case, electric field due to an electric dipole at any point on the axial line. We just want to find out this one. Just consider this is the electric dipole. At A positions plus Q located, at B positions minus Q located. The distance between the dipole is 12. Okay. So this is the axis of this dipole. On the axis we consider a point P, this one. So we just want to find out the electric field at the point P. Electric field means, that means if a unit positive charge is placed over there. So generally we just want to find out the force on this point P, that is the electric field on the point P. Okay. So consider the first one, the plus Q charge placed at the position A. This place at the position A. So what is the electric field? According to the Coulomb's law, we know that 1 by 4 pi epsilon naught Q1 into Q2 by perpendicular distance square. Here Q1, that is the plus Q charge. Okay. And the Q2, that is the plus 1 charge placed at the positions of P. So we just write Q into 1 by perpendicular distance between A and P. So we write here, that is AP square. Okay. So this one is positive, this one is positive, both are positive. So therefore, the forces between them obviously in repulsive in nature. So this repulsive force acting in the outward directions. So we just represent this one is E1. So this one electric field acting along the outward direction. In which directions? Along the direction of AP. Clear? So 1 by 4 pi epsilon naught. So we just write here 1 by 4 pi epsilon naught into Q by AP square. What is AP? This one, AP. So total distance from the OP. Okay. So OP equals to R. We just want to find out AP. So AP equals to AP, this one we want to find out. So AP equals to OP minus OA. What is OP? OP equals to, that is equals to R, the full form. Okay. So OP equals to R, and OA, this one equals to small l. So R minus L, that is equals to OP. So AP square, we just write here R minus L whole square. This one is E1 value. Again the next one, that is E2. E2, that is the electric field due to the negative charge, that is minus Q placed at the positions B. So B, we just want to find out the electric field at the positions P also. So again we write, that is 1 by 4 pi epsilon naught Q by BP square. So here, that is 1 by 4 pi epsilon naught Q by BP. BP means, that is this one. Okay. So what is BP? BP equals to, that is OP plus BO. OP plus BO. What is OP? OP equals to R. So we write here. What is BO? BO equals to L. So R plus L. So we just write here, that is R plus L whole square. Okay. So due to the dipole, total net electric field at the P, we just want to find out. So total electric field, that is E equals to E1 plus E2. What is E1? This value. So 1 by 4 pi epsilon naught Q by R minus L whole square. And E2 this one, that is 1 by 4 pi epsilon naught Q by R plus L whole square. Taking common, Q by 4 pi epsilon naught. So this one we write 1 by R minus L whole square. And here this one is Q is negative. So we write here negative sign because it is minus Q. So here it is also negative. So minus 1 by R plus L whole square. That is Q by 4 pi epsilon naught. This one R plus L into R minus L, that is R square minus L square. So R square minus L square whole square. And this one is R plus L whole square minus R minus L whole square. Okay. So now calculating this part, this one calculating this parts again now here. So E equals to Q by 4 pi epsilon naught R square plus L square plus 2RL. Okay. So we write in the lower portions. That means it's showing the other part also. So E equal to Q by 4 pi epsilon naught R square plus L square plus 2RL minus R square minus L square plus 2RL by R square minus L square power of whole square. So R square cancel out, L square cancel out. So only part remaining, that is Q by 4 pi epsilon naught 4RL by R square minus L square power of whole square. So it may be written in the forms, just check it out, 1 by 4 pi epsilon naught. This is written in the form 2 into 2QL into R by R square minus L square power of whole square. These 2QL terms, that is 4QL, that is 4QL into R. This may be written in the form 2 into 2QL. Now what is 2QL? 2QL is the electric dipole moment. So we just write in this space of, that is 1 by 4 pi epsilon naught 2PR by R square minus L square power of whole square. This one. Now if I consider for the dipole, that is the distance between the two dipoles tends to 0. That is this one R, the distance between them, that is R is greater than L. We consider, we know that according for the ideal dipole. So when R greater than L, so we neglect L square. Okay. So we just write in this case, that is E equals to 1 by 4 pi epsilon naught 2PR by R to the power 4. Okay. So R cancel out this one. So that means 1 by 4 pi epsilon naught 2P by R cube. This is the value of the electric field at any points on the axial line. Okay. Up to this part is completed. Next we move to the next cases. That one we want to find out the electric field at any point on the equatorial line. Just write down this part, then we move to the next one. So we move to the second case. The electric field due to an electric dipole at any point on the equatorial line. So this one dipole at the positions A, consider plus Q located, at the positions B, minus Q located. This is the equatorial line, perpendicular. At any point on the equatorial line, that is at the point P, we just want to find out the electric dipole. From the figure you just think about that, this is too much tough, not that. So at the point P, we just want to find out the electric field due to the electric dipole. Just simple consideration you consider. So this is the plus Q charge. We just want to find out the electric field. Which positions? At the positions P. Electric field, that means plus 1 charge is located over there. So here it is the plus 1 charge located. So plus Q plus 1. Obviously repulsive force given. So this force considered E1. So it is acted along these directions. That is AC. This one along this direction. So it is denoted with the E1. Okay. So next one, that is the minus Q charge. Minus Q charge located at the positions B. So therefore, the forces between minus Q and plus 1 obviously attractive in nature. So this force acted along the PB. This one is E2. Just check it out. This is arrow sign given and it is acting along the PB. So two forces acting one. That is the first one, electric field, that is along the directions of PC. This one E1 for the plus Q charge. And for the second one, for the minus Q charge, it is acting along the lower sides. That is E2, that is along the directions of the PB. So total distance between the dipole, that is, it is 12, that you know. So this equatorial line divides the dipole distance between them. That is, this one is L, this one is L also. And the distance of the P from the axis, we consider this one is small r. So this one R, this one L. So what is the distance of AP? So AP equals to, according to the Pythagoras theorem, AP this one from the triangles AOP. From the triangles AOP, this one is the triangle. From the triangles, hypotenuse square equals to length square plus breadth square. So AP square equals to AO square plus OP square. What is AO? AO, this one is small l, so small l square. And what is OP? This one is R square. This one is value is R. So this one is R. So we just write L square plus R square. That is equals to AP square. So what is the value of AP? This one, that is root over of L square plus R square. So just we write that one, that is this AP equals to root over of R square plus L square. So same way, that is the BP, because this is the equidistance, okay, equatorial line, the distance between them is same. So BP is also, that is root over of R square plus L square. So this one clear up to this. So E1, that is the force acting along the PC direction, that is equals to 1 by 4 pi epsilon naught Q by AP square. It is directed along PC. Okay. So Q by AP square, we just putting the value here. That is E1 equal to 1 by 4 pi epsilon naught Q by AP square. AP means this value, that is root over of R square plus L square. So we just write in this case R square plus L square power of half. And same way, we just write the E2. E2 equal to 1 by 4 pi epsilon naught Q by, so it is directly along PB, so Q by PB square. So this one is square, okay. So when we write the square, so in this, after that you write the square this one. So you neglect the power of half, that is the root value. So PB square, this one is PB. So PB square means that is 1 by 4 pi epsilon naught Q by R square plus L square. Okay. So this one E1 and E2. We just find out this E1 force, this E1 electric field acting along PC. Make some angle theta with the normal. So if I divided the E1 in the two parts, that is E1 cos theta acting along PF and another one, that is E1 sin theta acting along the PD. We just repeat once again, E1 acting along, make some angle theta. So E1 and one force is acting along PF, that is E1 cos theta. Same thing, E1 sin theta, it is acting along the perpendicular direction, that is PD. So another force, that is E2. E2 is also divided, E2 direction directly along. So it is divided again. So E2 cos theta acting along PF and E2 sin theta acting along the PO. So what is the forces? That is E1 cos theta, this one acting along the directions PF. So we just want to find out how many forces acting in this case. Next one, E1 sine theta along the directions of PD. Next, E2 cos theta along the E2 cos theta. This one E2, so E2 cos theta acting along the PF again, and E2 sine theta. This is acting along these directions of the PO. Now check it out in this case. This PD, that is E1 sine theta and E2 sine theta, these are acted in the same line but in the opposite directions. So E1 sine theta and E1 sine theta this one and E2 sine theta this one acting in the same line but in the opposite direction. So these are equal and opposite. So they are cancel out each other. So E1 sine theta and E2 sine theta. So we just write E1 sine theta equals to E2 sine theta. So we just neglect this part. So this one is neglected. Okay. Only two forces remaining, that is E1 cos theta and E2 cos theta. Okay. So we just find out the next case, the total value of E1 cos theta and the E2 cos theta. So total electric field, this one at the point P due to the dipole, that is E1 cos theta plus E2 cos theta. So E equals to E1 cos theta plus E2 cos theta. We just write here 1 by 4 pi epsilon 0 q by r square plus l square into cos theta, 1 by 4 pi epsilon naught q by r square plus l square into cos theta. This one. So these are both same. So we just write in this case, that is 2 into 1 by 4 pi epsilon naught q by r square plus l square, this one, into cos theta. Okay. So both this part, this total force electric field, both are cos theta terms. It is acting along the terms of PF. So along the directions of PF. Now what is the value of cos theta? Now from the triangle AOC, AOP, we just write from the triangles of AOP, this triangle, according to the Pythagoras law, we just write AP square equal OA square plus PO square. What is OA? OA, this one, L square. And what is PO? This one is R, smaller. So R square. So AP square, so AP equals to root over of L square plus R square. Okay, this one the value. So again, when we just want to find out the cos theta terms. Cos theta means that is the base by hypotenuse. What is base? That is equals to AO. So AO, and what is the hypotenuse? This one, that is equals to AP. So AO by OP. What is AO? AO equals to small l. So small l by root over of R square plus L square. R square root over R square plus L square. This one is the value of the AP. So just putting the value here. So that is 2 into 1 by 4 pi epsilon naught q by R square plus L square into cos theta. Cos theta means this value, that is L by R square plus L square power of 1 by 2. So writing this part in this case, that is 2 by 4 pi epsilon naught. Okay. So we just write. So that is E equal 2 by 4 pi epsilon naught QL by R square plus L square power is 1, and here it is R square plus L square power is half. So 1 plus half, this one, we just write here R square plus L square power of 3 by 2. Okay. Same way, that is the L, the distance between the two dipole is much less. So we consider L much less than R. So we neglect the L square. Okay, L square terms neglect here. Neglect. So we just write E equal, that is 4 pi epsilon naught 2QL by R cube only, because r square into 3 by 2 to cancel out, that is r cube only. Now 2ql, what is the 2ql? 2ql is the electric dipole moment. So we just write in this case, that is E equal P by 4 pi epsilon naught by r cube. So this is the value of the electric field, and it is acting along the directions of PF. PF is the directions. Okay, so this one, I think this is clear. The second case, this one, that is the find out the electric field at any point on the equatorial line. So now we want to discuss about the part that is the electric dipole in an uniform electric field. Okay, let's start with this. So next one, that is electric dipole in an uniform electric field. Just check it out. This A and B, these are the 2 points. The 2 dipoles is placed. This one is minus q placed over there and plus q placed over there. So this one is minus q and this one is plus q. Okay. So this field is uniform. Constant electric field is given, that is E constant electric field throughout of this. It is given over there. The distance between the A and B is equals to 2L. Now we just draw a perpendicular. This one is the point C here. We just want to find out the electric field. We just want to find out that is the torque tau due to this electric field. Why this torque appear? Because this one is Q. The uniform electric field, this one is E. So minus Q into E, this force acting along the downward directions. If I consider plus Q into E acting along the upward directions, so these 2 forces equal, but it is acting in the opposite directions. So first one acting in the downward direction, this one is minus QE, and another one it is directed in the upward direction, this one is plus QE. So 2 forces, just consider this one is minus QE and this one is plus QE. Both are equal, but in the opposite direction this one appear. So obviously a torque or couple is generated in this case. Okay. So torque tau, that means equals to, we just want to find out the value of the torque. Value of the torque tau equals to either force into perpendicular distance between the 2 forces. What is the force? Either force, this one is QE. If I take the mod value of it, so this one is Q into E, and perpendicular distance. What is the perpendicular distance? Perpendicular distance, obviously this one between the 2 points, between the 2 dipole is AC. This is the perpendicular distance. So we write here QE into AC. Now from the triangle, this part ABC, from the triangle ABC, we write here that is equals to AB by AC. So AC by AB, this one is AC, that is this one is considered just like that. This one is AC, okay, and this one is AB. So AC, that is the perpendicular, and this one is hypotenuse. So AC by AB, that is perpendicular by hypotenuse. This is equals to sine theta. So we just write here AC by AB equals to sine theta. So AC by AB, this one is sine theta. That means AC equal AB sine theta. So AB equal to, that is equals to 2L. That is 2L into sine theta. So we just write here that is QE into 2L sine theta. Okay. So we just rearrange this part. So torque tau equal 2QL into E sine theta. Now 2QL. What is 2QL? Now 2QL is the electric dipole moment that you know. So we just write here that is P into E into sine theta. So this is the value of the torque tau. Now if I consider the 2 cases, that is P sine theta, this one, when theta equals to 90 degree. Okay, so when theta equals to 90 degree and electric field is constant, that is equals to 1, if I consider, then torque tau equals to theta equals to 90 degree. So when theta 90 degree, then sine theta or sine 90 degree equals to 1. So putting the value, that is P into 1 into 1. So torque tau equals to P. That is for a constant unit electric field. Okay. And the angle between the dipole, this one is theta, that is equals to 90 degree. Torque tau equals to the electric dipole moment. This is the one of the definitions of the torque tau in this case of uniform electric field. Now another question arises. This is another one of the important questions for the board exam also. That is the vector form of the torque tau. So this torque tau, maybe you can just check it out, that is P sine theta. So torque tau is a vector quantity. So P sine theta. If I write AB sine theta, according to the formula, we know that it is A cross B. Mod of A, mod of B sine theta, that is equals to A cross B. So here P sine theta, it may be written in the form that is P cross E. So this is the vector form of this dipole. Vector form when the dipole is placed in the uniform electric field. Okay, up to this clear? So everyone read this part very carefully. This uniform dielectric, uniform field, this is very much important, and other two cases is very much important. So read this part and practice. This is the main important things. Write all this part, that is all these calculations in your copy regularly. Otherwise not possible to get the highest marks or good marks in your final exam. Okay, so best of luck. Keep watching my video. We come back again with a new video. Thank you everyone.